Hello, my name is Miss Nicholas. You can call me Miss Nick. Most of my students do. I'm going to be talking to you today about homeostasis. Homeostasis is a very important concept in your study of anatomy and physiology because it's homeostatic mechanisms that allow us to maintain a stable environment within our body, to maintain body temperatures and blood sugar levels, and several other things that we'll expand on as we continue our studies throughout this semester and the next. So let's begin by talking about what homeostasis is. Now remember, you want to maintain a stable internal environment. That is homeostasis. The world around you is constantly changing, and those changes can lead to changes in your body. We have to be able to maintain things at a certain set point. That set point is maintained by different mechanisms that we'll talk about. In order to do this, your brain, your body, your receptors, your muscles are all going to work together. So there are certain chemicals that are going to be used to change things in your body. There are body changes in temperature. And of course, the nervous system. The nervous system we'll be referring to, you'll learn more about later, but we're talking primarily about the brain and sometimes the spinal cord. And then the nerves that go out and cause things to happen in your body. So all of these interact and work together to maintain homeostasis. Now let's look at a couple of things that must be a part of a system in order for this to work. Things change in your body, as we mentioned. When those changes occur, it has to be detected. It's the receptors of your body that detect those changes. There are many types of receptors in your body. You have chemoreceptors that detect changes in chemicals. You have thermoreceptors that detect changes in temperature, and many, many others. So you've got that receptor that picks up that stimulus. It detects something has changed. Now that has to be sent to a control center. It's that control center that maintains those set points. That control center interprets that stimulus that's sent from that receptor and says, okay, something's out of its normal way of being, away from the set point. We need to cause something to happen to get it back. And that's when the effectors are called into play. The effectors are the things that are going to cause the change. So they cause something to happen. Let's use a quick example here. Let's say you're walking through your house barefooted and you step on something sharp. You step on a pin. That is detected by a receptor in your foot. Those are called nociceptors. Those are pain receptors. That stimulus is sent to the brain. Your brain interprets that, ouch, that hurts, and sends an action to the effectors, which are the muscles in your leg and your foot, to remove your foot off whatever is causing that pain. Okay, so those are the three players that have to be used in order for that to happen. All right. Now, one of the most common ways of maintaining homeostasis is to use a negative feedback mechanism. A negative feedback mechanism is one that works opposite of the stimulus. So it reverses the change. If your body temperature gets too high, then a negative feedback mechanism works to bring it back down to normal set point. So an example of this is regulation of room temperature. You're familiar with this already. You could probably tell me all the parts and pieces that go into maintaining room temperature, but let's relate that to the terms that we've already talked about. Your balance, the temperature that you set your thermostat, is your homeostatic range. So we'll call balance homeostasis. All right, so a change occurs. Let's say your room has gotten cold. So your stimulus is your dropping of the room temperature. It's detected by the receptor, which is the thermometer. The stimulus, the signal, is sent to the control center, which is the thermostat. The thermostat, remember, maintains that set point. Okay, so that's your control center. It causes an action to occur. Those wire signals turn the heater on. The heater is the effector. It causes the change, and the room temperature rises back to homeostasis. Just the opposite occurs if the room temperature gets too hot. Okay, so this is a negative feedback mechanism. The stimulus was a drop in temperature. The negative feedback reversed that, worked against the stimulus. See how easy this is to understand? Let's look at how this happens in the body. Here's an example of a negative feedback reaction in the body. The stimulus, this guy's eating a cheeseburger, so is blood glucose. Glucose is blood sugar. Blood sugar levels are rising. Okay? The pancreas is going to secrete insulin. Insulin works on body cells to cause those body cells to take glucose in. It causes the liver to store glucose in a different form, which is known as glycogen. Once again, the body cells take that glucose up and use that glucose to make energy. Now, as all this glucose is being taken into your liver and into your body cells, your blood glucose levels are declining back to homeostatic range. Okay, so remember, blood glucose levels rose when you ate. Your body worked in the opposite direction to bring those levels back down to normal. This is the way that most of the homeostatic ranges in the body are maintained. However, there are a couple of cases where we use a positive feedback mechanism. Positive feedback enhances the change, causes the change to be greater. So let's look at one here that's pretty simple to understand, and that is bleeding. Okay, if you bleed, you want to stop that bleeding. So you're going to employ mechanisms that cause blood to clot. So you have a break or a tear in the vessel, okay, in your blood vessel. You've got a cut. You're going to begin a process known as plating. You've got these little things called platelets in your blood that start to aggregate around that injury. And as they aggregate, they cause more and more and more and more platelets to come to that area, and they stick all around that broken blood vessel. As they stick, the clot is getting bigger and bigger and bigger. So the more platelets are going to be stuck, and then more and more and more until you have a large clot that grows and seals off that broken blood vessel. Now there's another pretty classic example of this, and this is when a woman is pregnant and going into labor. You'll see more about this later, but let's go ahead and talk about it now, and it may help you to understand this a little bit. When a woman is carrying full-term baby, and that baby is big, it's pushing down on the bottom of the uterus, which is called the cervix. That cervix contains receptors in there that detect stretch. Remember, that baby's getting bigger and bigger, so it's stretching that muscle. Those stretch receptors send a message to the brain. The control center in the brain is the hypothalamus. The hypothalamus detects or interprets that stimulus as, wow, cervix is stretching. That baby must be getting pretty big. It's time to have this baby. Let's get it out. So it sends a signal down to the pituitary gland, which releases a chemical known as oxytocin. Oxytocin causes smooth muscle stimulus, smooth muscle contraction. So when those smooth muscles of the uterus contract, it's getting smaller, it's pushing harder on that baby. The baby's pushed down more onto those stretch receptors, which send that signal back to the brain, which releases more oxytocin, which causes more contraction, which pushes more. Sort of get the picture here, right? So a positive feedback mechanism causes even more change to occur. Now, these are not the most common found in the body, but the regulation of blood clotting and oxytocin and labor during childbirth or preparing for childbirth are two of the most common. Okay, now, after you've completed this video, you'll be instructed by your little message there on your WebCT shell, on your Blackboard, we just changed, on your Blackboard shell to go to a particular animation on homeostasis. So when you click that, here's what you should see, and once you click Go to Animation, it will take you to that animation and reinforce some of these terms that I've talked about. All right, kiddos, I'll see you next time. Take care.